Hello friends, welcome to yet another episode of our Prep Station online tutorials, and today we'll be taking on friction. Now, what is friction? Friction is a force that opposes the motion between two solid surfaces which are in contact with each other. So if you have two solid surfaces which are in contact or they are in motion with each other, the force that exists between them is called frictional force. Normally, frictional force acts in such a way that it opposes the motion of solid surfaces which are in contact. And in that, we know that the frictional force also can be represented as weight, which is given as mass multiplied by gravity. Now, frictional force is directly proportional to the normal reaction. The normal reaction is the force that tries to oppose that motion. So if you have F directly proportional to R, so if you remove that constant of proportionality, you are going to have F is equals to mu R, and that mu is known as our what? Coefficient of friction. So the coefficient of friction can be represented as the frictional force all over the normal reaction. Now, there is static friction, which is the friction that is present between two bodies which are in contact, and then there is dynamic friction, which is the friction that is present between two solid surfaces which are in motion against each other. Now, if you look at the diagram that is drawn here, you can see that a body is sliding down through an inclined plane. And through that, you can see that the frictional force is acting against the plane while the normal reaction is coming down along the plane. So if you see that diagram there, if you want to resolve what the coefficient of friction is going to be given as W sine theta all over W cos theta, which is the same thing as force all over the normal reaction. If you resolve the force, you are going to have W sine theta along the horizontal plane, and then if you resolve the normal reaction, which is of the weight, you are going to have W cos theta, which gives you the normal reaction for friction. Now, what are the laws of friction? Naturally, friction opposes the relative motion between two solid surfaces. So that is the first thing we need to know. Friction opposes the force between two solid surfaces which are in motion, and it increases with the extent of the motion that is producing it. That means the higher the motion, the higher the friction. Now, friction depends on the surfaces that are in contact. The more rough the surface, the higher the friction. And the smoother the surface, the less the friction. Friction is also independent of area in contact. Friction can affect any area. It can affect any surface area, and it is proportional to the normal reaction. Now, what are the advantages of friction? Friction helps us to walk upright. The friction between the soles of our feet and our shoes makes us to walk upright. The friction between the vehicle tires and the road, the contact the vehicle tire makes with the road, makes driving possible. Friction allows a moving car to come to stop once the brake is applied. So the action of halting a moving car is possible by the process of friction. As the brake is applied, it slows down the traction of the car and the road, and then the vehicle is able to come to a stop. Now, in industry, fans and conveyor belts require friction to work. So you can see that friction is very, very advantageous to our everyday life. Now, what are the disadvantages of friction? Friction leads to wear and tear because mechanical parts, when they rub each other from time to time, they produce heat, and that heat leads to wear and tear. It produces heat. So when two solid surfaces are always in constant motion with each other, it's going to produce heat, and heat will lead to the inefficiency of machines. And because of that, friction reduces the efficiency of machine. The efficiency of every machine is reduced by the effect of friction on that machine. Now, after looking at friction, how can we reduce friction? Since friction occurs between surfaces which are in contact, how can we reduce friction? Number one, we can reduce friction by lubricating, by using ball bearings. If there are mechanical parts that require ball bearings can help to make the motion smoother. And then by designing shapes that have streamlined bodies, especially with vehicles and aircraft, so that when they move, they're gliding across. As they glide in the air, the streamlined shapes makes the motion easier and possible. So these are one of the few ways to reduce friction. Now, we have a few questions that we want to look at under this topic. So the first question reads, a force of 20 newtons applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kilograms move on the table. Calculate the coefficient of friction between the block and the table. From the introduction of the topic, we said that the coefficient of friction is the ratio of the frictional force and the normal reaction. The force has been given to be 20 newtons, while our normal reaction is the weight. The weight is given as mass multiplied by gravity. So the mass of the block here is 4 kilograms and G is given as 10. So if you find the ratio of the force and the normal reaction, you are going to have 20 divided by 40, which will give you 0.5. Now, a quick look at the options here. We have option A is 0.7, option B is 2, option C is 0.2, while D is 0.5. So from here, we can see that the correct answer to this question is 0.5. The next question here reads, a metal block of mass 5 kilograms lies on a rough horizontal platform. If the horizontal force of 8 newtons is applied to the block through its center of mass to just slide the block on the platform, then the coefficient of frictional force between the block and the platform is. This is similar to the question we just answered here. They are looking for the coefficient of frictional force. And the coefficient of frictional force is the ratio of the frictional force to the normal reaction. The mass in question here is 5 kilograms, while the frictional force, the horizontal frictional force, is given as 8 newtons. So if we convert the mass to weight, which will be 5 multiplied by 10, we'll have 50. So the ratio of the force to the normal reaction will give you 8 divided by 50, and then you have 0.16. Now, the coefficient of friction does not have units because both of them are represented in newtons and they will eventually cancel out. That's why you see that all the values here do not carry any units. Next question. A box of mass 40 kilograms is being dragged along the floor by a rope inclined at 60 degrees to the horizontal. The frictional force between the box and the floor is 100 newtons, and the tension on the rope is 300 newtons. The question is, how much work done in dragging the box through a distance of 4 meters? Now, there are 4 options here. The first option is 680 joules. The second option is 400 joules. The third option C, 200 joules. Then the last option D, 100 joules. Now, if you look at this question very well, you notice that, number one, the box is being dragged along an inclined plane. And what is the angle of that inclined plane? 60 degrees. Now, there is a tension that is operating on that rope that is inclined at that 60 degrees to the horizontal. So the first thing that we need to do is, now we need to find the resultant force, because we are asked here to calculate work done, and work done is usually force times distance. So we are going to get the difference between the force that is acting in the rope and the frictional force. If we are able to do that, then whatever we get, we now multiply it by the distance, which will give us our work done. So the force along the horizontal plane will be 300 multiplied by cos 60. You know that our normal reaction is usually W cos theta. So we are going to use that. So, and there, the tension in the rope is 300. So we multiply it by that angle, which will give you 300 multiplied by cos theta, which will give you 150 newtons. Now we need to get the difference between tension in the rope and the frictional force. And if you do that, you're going to have 150 minus 100. 150 newtons minus 100 newtons. And the difference will give you 50 newtons. So the resultant force that is acting on this body on this box at this time is 50 newtons. Now, what is work done? Work done is force times distance. And so we are going to use what we got as our resultant force here, which is 50, and we multiply it by 4, which will give us 200 joules. So if you go back to the question and you look at the options, you will notice that the correct option there is C, which is 200 joules. Thank you. Just a second. Friends, we will come back. Let's have a break.